So firstly, about the Traffic Technology Forum, we're funded by the Department for Transport and Innovate UK. We focus on local roads that are 97% by length of the UK road network, and we're helping local authorities understand new technologies and how to get ready for a digital future. One of the particular points about that is the way traffic signals work. Now, to many people, traffic signals are just magic in that they just go red, amber, green. But there are central computers, comms, and then there are grey boxes at the side of the road, which in modern parlance is called on the edge. But we've had those grey boxes called traffic controllers since the 1950s. And what they do is they stop traffic signals doing dangerous things. And they have what's called stages and phases, which allows which arm of the traffic runs green and the gaps between changes and so on. And those of you watch the Italian Job at the weekend, you cannot in the UK have a set of signals that go red and green at the same time due to this physical device called a traffic signal controller. They manage capacity and safety. We use detectors in the road, increasingly from connected vehicles, and we use pedestrian buttons to change signals. And these have complicated enough logic as it is, but if you have trams going through the middle or a signalised roundabout, sometimes these are very, very complicated things. The way that we would output the way that they work at the moment is on a paper form or a spreadsheet copy. There is no digital version of that that's available for connected and autonomous vehicles for future mobility. So as traffic signal engineers know what the signals are doing. So what we are aiming to do is to build a digital twin of a traffic signal controller that other people can access. So just very quickly, that's the sort of very simple junction with 4 arms and some movements. And the traffic signal controller determines which of those sets of traffic movements can run at which time, which can move from which to one another, and timings, and which detectors fire it all off. And we could go on for years about how traffic signal controllers work. The key thing is that there are lots and lots of use cases for having a digital controller in specification, all of which are about data connectivity and traffic management. And people say, oh, why can't we just read the traffic signals with a camera and determine if they go red, amber, and green? Well, the problem there is you don't know what the signals are going to do next. You don't know when they're going to change. And also, we don't have perfect traffic signal lamps, so sometimes they don't work. So what we're doing is to try and get a digital base model of the controller, and then a way to number those controllers so that each one is individually numbered, because we don't actually know how many traffic signal controllers there are in the UK. We think it's about 35,000, but many of them are not uniquely numbered because of the reason they haven't needed to be. And we see lots of benefits here to other digital twins. So there are lots of work being done on modelling of traffic networks of the roads that feed traffic into the junctions, but they take a very simplistic model of the way traffic junctions work, which we'd hope to improve. We'd like to link to other digital twins, particularly of the utilities below, so NUR and people like that, very important, and of the power and the comms networks that we connect to. As we just heard, power is important, but for us, comms network is too. And there's also a thing that's emerging, which is a digital twin of the rules of the road. So who can turn right here, height and weight and speed limits, and those are called digital traffic regulation orders, and that's maybe a subject for a later discussion. So DCIS provides a machine-readable, openly produced model of what's going on in a traffic signal controller. At this point, I'll pass over to John, who's going to talk to you about how actually we've been trying to produce a digital model of something that up till now has been a load of sheets of paper. So John.
Yeah, thanks, Andy. So yeah, I mean, we're starting at the very beginning here. You know, we're going from non-digitized to try and get a basic digital model and really prove the concept that it can be done. So we've split it out into 4 key areas. One is, or these are sort of artifacts that we see as being critical to be able to make a useful model of a signalized intersection. So first thing we're looking for is from each local authority or each road authority to produce just a basic list of where all their signals are. So this effectively is a GeoJSON file with a point location for each set of traffic signals, like the lowest level of detail. But to enable that, we also need a national identifier for each road authority, which there isn't currently, and also a numbering convention for intersections. as well. So that's another piece of work that we've sort of been consulting with through the Transport Technology Forum. And then a diagram just to act as a reference, which most local authorities already have for signalised junctions, but quite often it's hand drawn, or it's it's a single printout that lives in the controller cabinet. It's absolutely not digital. And then you've got more detail, which item 3 would be a more describing the geometry of an intersection. And there is a standard around this already that's come out of the CITS standards, so connected autonomous vehicles, and the messaging standards around supporting those, which I'll come on to on the next slide. And then item 4 is actual digitization of the signal controller configuration. So currently this is very much in the domains of the traffic signal companies themselves at the moment. There is a working group and a standard specification body that can do some sort of standardization of that, but they all have their own different way of implementing it. You can't, for instance, export a controller configuration from one company and import it into another from another provider. Next slide, please, Andy. So I've talked about standards. What we're trying to do here is essentially take the best bits of the existing standards. So the Department for Transport, they're in the process of digitizing all their traffic regulation orders. That's a separate project, but something that can be we see as could be useful for this project, because this would enable you to cross-reference between what a signalized junction is actually programmed to do in terms of permitted right turn, and where that's actually stated in the traffic regulation order. So it allows for some cross-referencing between those data sets, which doesn't exist at the moment. There's some international and European CITS standards. There's a working group called C-Roads, which involves various parties, signal companies, the automotive industry, which are developing 2 key specifications for us, which is MAPM and SPATM. So MAPM describes how you define an intersection in terms of its lanes, the lane geometries, the permitted turning movements, and so where you can turn when lights turn green. There's also the UK traffic signal industry. Transport Technology Forum is part of that, and they're all members of that. There's the RTSM network, which develops specifications through a framework called Topaz, which develops traffic signal controller specifications. But at the moment, it's a specification, but is open to interpretation when it gets down to the actual implementation level. So we're trying to standardize that at a digital level so that we have a standard traffic signal controller specification that can be used across vendors. So what we're essentially trying to do is glue all these different standards together. Just the first thing we need to do here is come up with a standard numbering convention. So the CITS standards dictate that a road authority should have a 16-bit integer as its ID. This doesn't currently exist. So this would, for the UK, require like the DFT to maintain a national register of road authorities, which in itself is no small task, because they don't align perfectly with local councils. For instance, you've got some national providers like National Highways, you've got private operators like people who run roads at airports and things like that. So it's quite wide in its scope. We've got the concept of a site, which is what a lot of local authorities are used to working with, but actually that part of the identifier wouldn't necessarily be used in MAPM. And then you've got the actual intersection ID. So the idea being that the combination of authority and intersection would be give you a nationally unique identifier. And the MAPM standard also now has introduced a country code, which could actually lead to having a internationally unique identifier for each signalized road junction. Okay, next one. And this is just sort of an overview of how the MAPM standard defines an intersection. So each lane is numbered. You then you describe a lane in terms of a set of nodes denoting the center line extending from a central conflict area. and then you define a trajectory, and then you essentially maintain a list of allowed connections between lanes. So this is just an overview of what that looks like.
Okay, so just to wrap up very quickly, the benefits are a full digital model of the road network and things that are below it. We make it easier and cheaper to model junctions, both in real time. We allow people like connected sat-nav suppliers and future autonomous vehicles to find out what's going on a signals basis rather than trying to read a PDF. We allow a load of new services. We make it easier to plan utility works that don't dig up our sensors. We can improve the asset management of signals, and we allow cheaper and better keeping of records, and lots of other benefits to start digitization of signals. And to answer the question that's come up, we've had smart traffic signals that adapt to traffic conditions for about the last 40 years, systems like Scoot, Mover, all of which require still traffic controllers, but they have a centralized traffic computer. So thank you very much for that. That's our contacts. We'll move to Q&A.